Hey friends! Today let's do Leetcode number 146 LRUCache. And this problem is to design and implement a data structure for least recently used cache. And we will provide two operations, get and put. If the key doesn't exist when you get, then we return -1. And if we keep putting key and value pairs in the cache, and if it reaches its capacity, we will remove the least recently used node. So for this problem, since we will try to do both operations in all one time, I will use a map and a doubly linked list for the order. So let's write a doubly linked list first. I'll create a D node, and it includes a key value, a value, a next node, and a previous node. I will have the key and value to initialize this node. In this LRUCache class, we're going to have a head and a tail, and everything are going to go in between the head and tail so that we can easily locate the least recently used node, and when we access a node or when we add a node, it will be easier for us to locate where to add this node. And for the map, I'm going to have integer as the key and a D node as the value. Also, we're going to have a capacity and a size for the current size of the cache. So when we initialize this LRUCache class, we want to initialize the map first. It's going to be a hash map, and the size is going to be 0. Head, I'm gonna give it some dummy values like -1, -1. Now point head.next to a tail, and tail.priv to head. And then we assign the capacity to the capacity. So when we try to get a value from the cache, we check first and see if this map contains the key. If it does, we will bring the node to the front and return its value. Otherwise, we return -1. Similarly to the put function, we're going to check if the map contains the value, contains the key. If it does, then grab the node, update its value, and bring this node to the front. Else, that means we're adding a new key. So here we need to increase the size, and then we'll check if the size is greater than the capacity. Then we pop the tail, remove it from the map, decrease the size, and then we create a node with this key and value pair and put it in the map, then add it to the front of the list, the double link list. With that said, we need some more methods to help us adding. Removing. And we'll need a method to bring it to the front. So for adding a node, we just need to add it in between the head and the first node. So we will make the node.next equals to head.next. Head.next.prove to point to node, and head.next point to node, and node.prove point to head. To remove the node, we will make this node's previous node.next node equals to node.next. And node.next.previous node equals to node's previous node. Actually, I think it needs to be void, not int. And then if we want to bring something to the front, we just need to remove the node, and then we add the node. Since adding a node will always add it to the front. So bring to front. This. Bring to front here. When we pop the tail, we need to get the last node first, which is going to be one node before the tail. And I'm going to remove the node, remove it from the map. And decrease the size. And here, after we remove the last node, we want to add this new node. Let's take a look at it. So we have the head, the tail, the map, capacity, and size. When we initialize the LRUCache, we initialize the map, set the size to 0, initialize the head and tail and point them to each other, and then set the capacity. When we get a value, we check if it's existing in the map. If it does, then we bring it to the front first, and then we return the value. Otherwise, we return -1. When we add a node, we check if it's existing in the map. If it does, we update its value and bring it to the front. If it doesn't exist in the map, that means we have a new key, and we increase the size first. If it's greater than the capacity, we need to remove the last node, remove it from the map also, and decrease the size. We create a new node, put it in the map, and add the node in our list. So some of our helper functions, we have add node to add it to the front. So we make the nodes next equals to heads next dot proof, pointing back to the node, heads next, point to the node, node dot proof, point to the head. Remove node, we point the node's previous node's next node to the node's next node. So that skips the node. The node's next node's previous point to the node's previous node, so that skips node. When we bring some nodes to the front, we remove it first, and then we add it to the front. Alright, let's run it. Whoa. What did I do? Okay. Alright, it runs. Submit. Yay! Alright, that's it today. See you next time.